Algebra 1, lesson 116, page 490. Quotient rule for square roots. Quotient rule for square roots. Now, I'm not going to do this yet because for whatever reason, so many of you are still struggling with this. I don't know. I can only keep saying the same things over and over again. Separate this out into two square roots. Well, that's not 8. That's supposed to be a 6. 6 times 100 is 100. The square root of 6 is just the square root of 6. 2 times 3, nothing I can do there. Square root of 100 is 10. You're done. You guys, you're killing me. You're killing me. You're killing me. Something like this right here. Again, I can only just keep repeating myself over and over and over again because there's nothing new to say. There's no new way to teach it. You just have to get this someday. I'm going to separate this into a multiplication problem. I want an even number of zeros here. 1, 2, 3, 4, 5. That's not an even number. So I'm going to do this. The square root of 50, the square root of 10,000, 4 zeros. Yes? I hope you understand this times this is that. 50 times 10,000 is 500,000. This is the, this should be the hard part. I don't know, I don't get it. I'm going to separate this out into another multiplication problem, okay? This is the square root of 10 times the square root of 5. I'll try this a different way. 10,000 is 100 times 100. How about this? 100, right here. 4 zeros. I don't understand. There's got to be some way for you guys to see this, okay? Now, this one isn't going to work. That's not what I want. I want 25 times 2, okay? Because 10 and 5 doesn't get me anywhere. This does. The square root of 25 is 5. The square root of 2 just is the square root of 2. The square root of 100 is 10. The square root of 100 is 10. Okay? This is that. This is that. That is that. That is that. Some of you you just have to get this sometime. 10 times 10 is 100, times 5 is 500, radical 2. Y'all are still having a super hard time with this. And I can only just keep showing it to you over and over and over again until you get it. Set it up into 2 multiplication problems. Turn this into 2 multiplication problems. Turn this into 2 multiplication problems, if that helps. My way of thinking, this is 10 to the 4th. The square root of 10 to the 4th is 10 squared. Because I divide that exponent by 2 and it becomes outside there. The 10 to the 2nd is 100. This is still 5. This is still radical 2. 500 radical 2. I don't care which way you do it, but y'all, you have to start getting this sometime. Okay? That's not hard stuff. All right. Because I know how much you love radicals. Quotient rule for radicals is this. In a fraction, you're never allowed to leave a fraction with a square root in the denominator. It's not accepted. Okay? It's against social distancing rules, all that stuff. You cannot have it. So the quotient rule says we can split this up into 2 problems. Radical 5 over radical 3. Now the problem with this is I'm not allowed to have a radical on the bottom of a fraction. So I need to multiply this by something to get rid of that radical. So if I multiply by itself, radical 3 over radical 3. Square root of 3 over the square root of 3 is equal to 1. I haven't changed the fraction, right? On the top, I have the square root of 15. On the bottom, I have the square root of 9. 3 times 3, like that. The square root of 9 is 3. Now, Elijah and others, you cannot reduce that. You cannot reduce that. This is not under a radical. This is under a radical. I can only divide inside of a radical to inside of a radical. I can only multiply outside a radical to outside, okay? That's it. That's the answer. That's done. That is not reducible. That is the answer, okay? So you separate this up into two radicals, radical divided by radical. No radical on the bottom. So to get rid of the radical, I multiply by itself, top and bottom. The square root of 5 times the square root of 3, that's fine. That's the square root of 15. We're done. That's it. 3 times 3 is 9. The square root of 9 is 3. We're done. There is no reducing here. There is no reducing there. You cannot do that. Do not do it. All right? So that's the easy part. Now, the fun part is this. Again, not allowed to have a radical on the bottom. So I'm going to multiply top and bottom by radical 5, radical 5. This is called the distributive property. Whew. That times that is just that. It's just 2 times radical that. Plus this times this, 5 times 15. Okay, 5 times 15. Okay, 15 times 5, 25, 7. What that gives me is the square root of 75 over 5 times 5 is 25. The square root of 25 is 5. That cleared the radical off the bottom of my fraction, which is my goal in life. No radicals on the bottom of a fraction. But I'm looking at this and saying, I need to reduce that. Okay, so we have 2 radical 5 plus 75 is, excuse me, 25 times 3 over 5. Okay, that is 5. You have to do this, guys. This is 2 radical 5 plus 5 radical 3 over 5. Now listen to me. Ain't nothing in the world you can do from here. Please, do not do that. You cannot cancel into part of an addition problem. If I can't take it in there and there, I can't take it into there. I hope you understand you cannot take it into there. Okay, I can't take it into here and here. This is just the answer. You can't add them together. You can't reduce it. And that's the answer. The goal in life is to get rid of the radical on the bottom, on the denominator. If there's just a single radical, multiply top and bottom by itself. This times this is going to be itself without the radical. Distributive property, we have this. If you can simplify, you have to. If you can add like terms, do it. If you can reduce, do it. But don't do it if it's not okay to do it.